first type of system of wave we called as the longitudinal wave. Okay, what is this? And the second type of wave we have that we called as the transverse wave, longitudinal wave and the transverse wave. What is the core difference between longitudinal wave and transverse wave? So to understand that, what we are doing is, let's say there are a couple of students standing in a row. So A, B, C, D, and there are a lot of students. Okay, so they make a queue. Okay. One instruction is being set to this guy that you need to sit and stand. Okay, like in a flow. And when this guy is sitting, this guy will be standing. The moment this guy is standing, he will sit and then we will continue the motion. So how does the system will look like? Let's say this person sitting, this is standing, 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 and standing. When this guy standing, this is at sitting, standing, standing, standing. So what you will find, it will form a wave like this. Okay. If you like see all these part. So when and the transfer, basically the transfer is happening in this direction. Okay. That whatever be the set of instructions are happening in this direction. And students are making motion in this direction. Basically up and down is the motion of student and the transfer is happening in that direction. So when motion of wave is perpendicular to the motion of particle. So these students you can consider as a particle. So when the particle is moving up and down and motion is happening in another direction. So if I say in general that motion of wave is perpendicular to the motion of particle, that type of wave we call as the transverse wave. Okay, no need to write anything now. I'll give you time. The second thing which when I do that when these students are moving like this and wave is also moving in that direction. So when wave propagation and particle motion is in the same direction, that type of wave formation we called as the longitudinal wave. Okay. If you see in case of slinky or spring, you will find that this type of motion basically with the particle and wave is also moving in that direction. So you will see a continuous compression, rarefaction, compression, rarefaction, and compression. So this is happening in this direction and the particles are also moving in that direction. So that type of wave we called as the longitudinal wave. So the standard definition of longitudinal wave comes a waves where points along the length vibrate parallel to the direction of transfer of energy. Basically wave motion and that their vibrations are parallel to each other. So that type of motion we call as the longitudinal wave. Energy transfer is in the same direction of wave. Energy transfer, but particles not in the particle of a medium. And yeah, the spring motion, sound wave are the best example for the longitudinal wave. So write a heading as a longitudinal wave and note couple of pointers from the slide. Okay, done?
Yes.
Okay. So, Ayan, Nigel, noted.
Just 1 minute, sir. Last line.
Yes, sir. I'm done.
Yeah, done, sir.
Okay. The second type of wave, as I told you, we call as the transverse wave. In case of transverse wave where points are along length vibrate at 90 degrees to the direction of energy transfer. So basically particles motion is perpendicular to the wave propagation. So energy transfer and particle motions are at 90 degrees to each other. So that type of energy transfer or wave we called as the transverse wave. Okay. The energy transfer is in the same direction of wave motion. Energy transfer, but particles, not the particle of medium. The line of this line means that particle are not going from here to here. If you see this red particle, it will move like this only. And this another particle will also move like that. So particle are not traveling, but due to their travel, the wave is traveling. Okay. In case of string, we see these type of wave, and even the light also is of this nature. So all electromagnetic wave. Light is one of a electromagnetic wave. They can move in solid, liquid, and gases. Even in vacuum, they does not require a medium to flow. So that type of wave we call as the transverse wave. Note it down. Just write the definition part. Rest all will clear.
I'm done.
Done? Okay. Ayan, Nigel, done? Ayan?
Yes, sir.
Okay.